So today we're going to take a look at day 14, continuity on a graph at intervals of increasing or decreasing. So the first thing we're going to talk about is what does it mean to be discontinuous? Discontinuous means it has a break in it. And don't worry about what type of discontinuity they might have, but these three graphs just clearly have a break. Now, two graphs that don't have a break are linear graphs, straight lines, as well as quadratics. Something like a cubic as well, those parent graphs we were looking at were all continuous graphs here. Now you can take a look at a graph and decide if it's discontinuous or not. You can just look at it. For example, we know this 1 over x graph. This one would be discontinuous. We can clearly see that. We could also see if it's discontinuous by plugging in the value 2. Well, not always 2, but in this case we want to know if it's continuous at 2. So we have 2 minus 2 over 2 squared minus 4. 0 over 4, 0 over 0, and we can't have this, so it must be discontinuous. If we look at a graph of this one, clear this out. We have x minus 2 over x squared, x squared minus 4. It's tough to see that x equals 2 on the graph. I believe even if we were to zoom in there, it doesn't look like it's discontinuous. It looks at negative 2. But as we zoom, yeah, we still can't see that, but if we bring up the table, Control T, if we look at 2, it's undefined, and that's because there's a slight hole. On this graph, we'll talk a little bit more about this in chapters coming up. At negative 2, it jumps from one part of the graph to the next, and at 2, there's this tiny little hole, because we see if we plug in 2, we end up with 0. So if you can't tell from a graph, check that point that they give you. The second thing we're going to look at is critical points. On a graph, it might have quite a few ups and downs. The tallest points, these are our maximums. And one of them is called the absolute max is the highest. Relative max are those other high points. And then we also have the minimums. So we have, in this case, just a relative minimum because it does go lower at other places. So to find these on your calculator, whoops, that's not the calculator, we have to type it in. So let's clear this out. And let's see, 2x cubed minus 3x squared. And what do we have? Minus 12x plus 3. So we might need to change our window. It doesn't look like we need to go out to negative 10, so menu, window settings. I bet we could go out to negative 5, but we can't see the top and bottom. So let's go from negative 20 to positive 20, and we'll see. And now we can see those max and mins. So to actually find them on the calculator, we hit Menu, Analyze Graph. We're finding a maximum. And this vertical line shows up, and it says lower bound. So that means we go to the left, to the right, and the coordinate shows up. And we can do the same to find our minimum. We go to the left, to the right, and there's our minimum. So this graph, this was the coordinate negative 1, 10, and 2, negative 17. So here's our max. And here's our minimum. And then we have to determine those intervals of increasing and decreasing. So it's increasing, obviously, when it's going up. And it's going up in these two sections. So we always reference our x value. So it's increasing when x is less than negative 1, but it's also increasing when x is greater than 2. And then we can take a look, well, when is it decreasing? Well, it's decreasing in between these values here. So it's decreasing when 10 is less than x is less than 2. It's excuse me, this should be negative 1. We always reference our x values, so in between negative 1 and 2. Now this next one I'm going to have you try in class just to practice pressing those buttons to find the max and min. But what I would like you to do is open up your assignment. So pause the video, take out your assignment, the day 14, and we're going to take a look at a problem on here. So let's take a look at number 9. We're asked to find quite a few things on here. The first one is the domain and range. So our domain, our smallest x value is negative 4, our biggest is positive. So negative 4 is less than or equal to x is less than or equal to 4. And then we have our range. Well, it goes from our lowest to highest, 0 up to 3. 0 is less than or equal to y is less than or equal to 3. And we include those values because they're closed in circles. Letter B asks for our x-intercepts. Well, where does it cross? At negative 2 and positive 2. And then it also asks for our y-intercepts. Our y-intercept right here would be 3. And then we're asked for where is it increasing. So let's see, I'm going to highlight that. It's increasing here and here. Then I'm going to underline those x values to remind myself we always use the x values. So it's increasing between negative 2 and 0, and then it's increasing again when x is greater than 2. Oh, but it stops there. So I should have that in between values again. So we have 2 is less than x is less than 4. And then D asks us where it's decreasing. So it's decreasing right here and right here. So it's decreasing when x is between negative 4 and 2, and then again between 0 and 2. So why don't you try the rest of these for tonight's assignment?